Welcome. In this video, we'll discuss the steps to configure and run a GCBM project. The GCBM uses a number of configuration files to run a simulation. The active configuration files are stored in the Gcbm_project folder, and the templates used to generate them can be found in Gcbm_project/templates. There are general types of configuration files: provider configuration files, which define all of the data sources that can be referenced by the modules using file paths that are either absolute or relative to the directory from which the GCBM was executed, and project configuration files, which define everything about a simulation: the modules to run and their order, all of the carbon pool names in the simulation, and the data variables and how to retrieve their values. Many of the project configuration files, or config files for short, contain settings required for the proper functioning of the model, but aren't typically modified by users. These include files with internal variables used by the model, module configuration where users might occasionally disable a module for debugging purposes, a carbon pools file that typically isn't modified, but it may depend on the modules being run, and a spin-up file handling the carbon pool initialization step at the beginning of the simulation. The configuration files most commonly modified by users include local domain.json, modules_output.json, and variables.json. The local domain.json file includes the start and end years of the simulation and the number of threads that the model is using. When adjusting the thread count, match the number of cores in your computer up to a maximum of 10, after which performance tends to decrease. The modules_output.json file controls the output modules, making it particularly useful for adjusting the spatial output. Ecosystem indicators can be turned on and off, and new indicators can be defined. The GCBM has the ability to report on any numeric variable, pool or combination of pools, or combination of fluxes. The variables.json file holds all of the data variables and tells the model how to retrieve their values, either a hard-coded value in the config file, from a spatial layer, or from a database query. A user could update this file to read data from a spatial layer instead of a query, or vice versa depending on the specific project's requirements. Even though some of the configuration files can be modified by users, most simulations can be run without making any modifications. The scripts in the template project set up the config files automatically from the template files located in Gcbm_project/templates. For users who aren't familiar with editing JSON files, contents of a modified JSON file can be validated with the tool available at the link displayed. The most common parameters to edit are thread count and the start and end dates in the local domain.json file, and the spatial outputs in the modules_output.json file. Displayed here is the spatial output config file with a number of spatial outputs defined. For example, the AG_biomass_C indicator outputs all of the above ground biomass carbon by adding up the 6 carbon pools listed here. Users can enable and disable individual spatial outputs by modifying the enabled setting, true or false, in each one. Another batch file in the Gcbm_project folder called update_gcbm_configuration.bat can be run once the tiler and recliner to GCBM steps are completed in order to render the whole configuration up to date. This configuration step is also part of the run_all.bat file that has already been discussed. To run a GCBM simulation, users can employ the run_gcbm.bat file in the Gcbm_project folder. Like the configuration step, running the model is also a component function of the run_all.bat file. In the next video, we'll describe how to run the post-processing tools.